Alright, my friends, so today we're going to do something we've been doing basically all of chapter 6, but we've got one extra step. So we already know our total number of zeros or roots is based on the degree of the polynomial. So this includes a combination of all of our real zeros and our imaginary zeros. Imaginary roots, this part's super important. So imaginary roots come in pairs. And we'll talk more about that on the back page. They come in conjugate pairs, so change the sign on the I part. We'll talk more about that once we get there. Alright, so the first page we are just factoring and solving some of these things. So we're only going to do 2 problems just because we've been doing this a lot. So let's do number 2 and we'll do number 2 up here. So, couple of things. I see degree 5. So that means that I need to have 5 zeros. So first step when factoring is GCF. So I'm going to factor out an x, and I'm left with x to the power of 4 plus 2x squared plus 1 equals 0. Alright, so I've got x. Now we need to try to factor this. Can you think of 2 numbers that multiply to 1 and add to 2? Nice work. 1 and 1. So I've got x squared plus 1 times x squared plus 1. Since these are the same, they're going to produce only one, like the same 0. But here I'm going to get one solution. Here I'm getting 2 solutions because that's x squared. And here I'm getting 2 solutions because that's x squared. Now I can't factor those any further because it's the sum, not the difference. So here, setting this equal to 0, I get x equals 0. Here we got x squared plus 1 equals 0. And the same thing's going to happen over here. So we don't have to do it. But I'm going to subtract the 1, take the square root, plus or minus I. So I've got 3 solutions, and this one is going to give me plus or minus I as well. So factored form, we're at x times x squared plus 1 times x squared plus 1. My zeros or roots or solutions. I'm at 0 plus or minus I. Now for our x-intercepts, this part's super important. Imaginary numbers never, ever, ever, ever cross the x-axis. So my only x-intercept here, and you can graph this on your calculator and you'll see that this thing only crosses the x-axis one time. And that one time is at 0, 0 again because imaginary solutions never cross the x-axis. So we have those solutions, but our only x-intercept is 0, 0. Alright, and then let's do number 1 down here, and then we'll flip to the back. Find all of the zeros. This thing is degree 3, so I better find 3. So I've got x squared plus 2. Oh, can't factor any further, so this is factored form. So I've got x equals 0. And solving this, we've got x squared equals negative 2. So x equals plus or minus I root 2. So there's my 1 solution and my 2 solutions. Now again, for my x-intercepts, my imaginary solutions do not cross the x-axis. So my only x-intercept here is 0, 0. Right, so that should be a review. Now let's flip the page. Yesterday they gave us a factor and we had to find the solutions. Today they give us the solutions and we need to find the factors. I'm going to cross out this polynomial part. We're not going to distribute all of that. I'll tell you only one thing we'll have to do extra, and we'll do it on number 2. So this comes to play where it says additional zeros. If I have any imaginary zeros, I have to make sure I'm including the conjugate pair, because they always come in pairs. Why do they always come in pairs? Well, if you were to solve x squared equals negative 25, when you take the square root, you get plus or minus 5i. So we get the positive 5i and the negative 5i. So if you have any imaginary solutions, you have to make sure to include the other. So number 1, it says write a polynomial of least degree with integral coefficients that have the given zeros. All right, we could do that. So here looking, I have 3 zeros, so I'm going to have 3 factors. I don't have any imaginary zeros, so I don't need any other additional zeros. I'm writing a function, so I have to name the function. I'll call it f of x. You can call it g of x, h of x, whatever you want to call it. If -4 is a solution, x plus 4 is a factor. Remember, when you solve it, instead it equal to 0, it better equal -4. So then I also have x plus 3 and x minus 5. Your factors are the opposite of your solutions. Now, where it says polynomial, it's asking us to multiply that all together. I am fine with us leaving it just as our factors. Okay, we're just going to do 2 more. So we'll do 2 and 3. All right, here, additional zeros. Well, I see that -3i is a solution, so that means that +3i also has to be a solution. As for our factors, I'm going to call it f of x again. I've got x plus 3, x minus 1, x plus 3i, and x minus 3i. Now, I'm not going to make you multiply this entire thing out, but what I will tell you is in factored form, we never have imaginary factors. So I do need to multiply those two things together because we can't leave our solution having those imaginary factors. So I've got x plus 3, x minus 1. So here you're going to distribute, 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 distribute. So I've got x squared minus 3xi plus 3xi minus 9i squared. So we'll simplify x plus 3, x minus 1, x squared. My xi's cancel out. I squared is a -1. So -9 times -1 turns to a +9. And there we go. So this would be our final answer here, getting rid of those imaginary solutions and calling it a day. All right, for the very next one. This one's a little trickier because my imaginary solution here is 4 minus 3i. Conjugate is 4 plus 3i. So, again, f of x equals x plus 2, x plus 3. Okay, that 4 is positive, so I've got x minus 4 minus 3i. And I also have that 4 is still positive, so x minus 4 plus 3i. Now again, I can't leave those solutions as imaginary factors. So this gets a little tricky. We have to do a lot of distribution. First, I'm going to distribute this negative sign so I can get rid of those parentheses, and that'll make our lives a little bit easier. So I've got x minus 4 plus 3i, and I've got x minus 4 minus 3i. And now we're going to have to distribute everything to everything. So I'm multiplying. Beginning stays the same. Okay, so I'm multiplying my x, my x by -4, my x by -3i. Then we're going to move out -4 times x, -4 times -4, -4 times -3i. And all of my i's are going to cancel out. It's just a matter of doing our multiplication. X times x is x squared. X times -4, we've got -4x. Here I've got -3xi. Now I can move on to my -4. Again, another -4x plus 16 plus 12i plus 3xi minus 12i minus 9i squared. Whew, all right. It looks ugly, but all of our i's end up canceling out. I've got a -3i and a +3i. We've got a 12i and a -12i. And we know that I squared is equal to -1. So that's really a plus 9. So we're at x squared. Minus 4x, so minus 8x. And 16 plus 9 takes me to plus 25. And then I have these two factors here. Alright, last but not least, so we're done with our notes, but what I want to say is you can always go back and check your work. Now that you have the quadratic formula in your calculator, if you put this in there, so A is 1, B is -8, and C is 25. If you put that in your calculator, it should give you these zeros of 4 minus 3i and 4 plus 3i. One thing that you'll need to do is change your mode in your calculator. And in your mode, it will say real, and then it'll say A plus BI. You'll want to highlight A plus BI so that it is able to give you those imaginary solutions. Alright, so that's it for our notes. Let's take a look at your homework. I am going to take some things off, and you can see those taken off things on the answer key. So you don't have to do standard form. Standard form wants you to multiply everything together. The only thing I want you to make sure you're doing is getting rid of those imaginary solutions. So on number 2, you've got 2i and -2i. Make sure you multiply those together to get rid of those in your factored form. Same thing for number 3. Numbers 4 and 5, they give you the graphs. They want you to write the zeros and the factored form. You do not need to multiply those out in standard form. And then here on number 7, I used my calculator to get that quadratic formula. So that's why I have those decimals. That's perfectly fine. And then you can skip number 8. All right. So for tomorrow, I am checking your 6-6 homework and your 6-7 homework. So if you didn't do 6-6, you have an extra day because you have the opportunity to be here and do that extra homework. All right, I'll see you tomorrow.